Okay, we're here with Luke to do just a quick warm-up on ratios, proportions, and percents. Ready to go?
Yeah.
Okay, so first ratios and proportions. I'm going to show you a table here about a relationship between x and y. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 6. Do you see kind of a pattern here? How would you describe that pattern?
Well, every time there's x, y multiplies it by 2.
Okay, so you multiply x by 2 to get y, right?
Yeah.
And when we have it, that's called a proportional relationship. And the number that you multiply it by is called the constant of proportionality. So here, like you say, the constant of proportionality is 2. And another way to think about this is if you divide y by x, it's always going to be the constant of proportionality. So 2 divided by 1 is what?
1. Or, sorry, 2 divided by 1 is 2.
Good. What's 4 divided by 2?
2.
What's 6 divided by 3?
2.
Okay, so every time you divide y by x, it's 2. Or it's the same thing as the constant of proportionality. Okay, you see how x and y are related in this way?
Mm-hmm.
Okay, so then what we can say is also that the ratio of y to x, because that's what a fraction is like, is a ratio, is 2 to 1. Okay, does that make sense also? Because 2 is like 2 over 1. Okay, and we can also write that ratio as y to x equals 2 to 1. The ratio of y to x equals or is 2 to 1. Just a different way of writing it with math. Does that review make sense?
Yeah.
Okay, now another thing, because these are proportional, this is a proportional relationship, we can graph it and it's going to have a certain pattern. Let's look at the graph. Okay, so what I've done here is I've taken the points where x is 1 and y is 2. So here I've graphed it with x is 1 as y is 2. And then the next point up there, 2, 4 I've put on there. I've put 3, 6. And I just kept on going. I even added another point that would fit the pattern, 5, 10. What can you say about these points? How would you describe the pattern that you're seeing graphically?
Well, it's a straight line.
It's a straight line, right? The points line up in a straight line. And I also put another point over here. What's this point?
Just 0, 0.
0, 0. Now, could we say that if you multiply x by 2 to get y, if you multiply 0 by 2, you would get 0? So would 0, 0 fit the pattern?
Yeah.
Yeah, it would, right? So what we can really say about a proportional relationship when you graph it is that the points are in a straight line through the origin. And you know that the origin is that point 0, 0, right?
Yeah.
Okay, great. So that's a quick review of ratios and proportions. Now let's talk about unit rates. So let's talk about this problem here. Mylene runs 7 miles in 35 minutes. What's her unit rate in minutes per mile? So how would you set this up to find minutes per mile? What fraction would you create?
7 over 35.
So 7 would be miles per minute, which would also be a very interesting unit rate, but this one asks for minutes per mile. So how would you set that up?
35 over 7.
35 minutes over 7 miles, right?
Yeah.
So we're just basically creating a fraction that gets us the kind of unit rate that we want. And then we can divide the numbers. What's 35 divided by 7?
5.
5. And then we just write minutes per mile, which is the units that we have left. So we kind of think about the numbers separate from the units. And this is a unit rate because it's per 1 mile. 5 minutes per 1 mile, or 5 minutes per mile. Okay?
Okay.
And that's how we say it. So at that rate, how many minutes will it take to run 3 miles? So if she would just went 1 mile, it would be how many minutes?
5.
5. If she was 2 miles, it would be how many minutes?
10.
Okay, so you're multiplying there. 1 times 5 is 5. 2 times 5 is 10. So now use the same thing. What would you do to find the number of minutes it will take her to run 3 miles?
5 times 3, which is 15.
Good. So 3 times 5, or 5 times 3, equals 15 minutes. So to go 3 miles, it will take her 15 minutes. Make sense?
Yeah.
Okay. Now let's quickly talk about percents of numbers. First, let's talk about some percents you probably have memorized. What's 50% of 18?
9.
9. And how did you do that in your head?
Well, 50% is half, and half of 18 is 9.
Good. So you've memorized that 50% is just like half. Let's see if there's another percent you have memorized. What's 25% of 40?
10.
10. And how did you do that? What did you do in your head?
Well, 25% is 1/4, so 1/4 of 40 is 10.
Good. Very good. Very good. So you've memorized that one too. And how about this one? 10% of 70. What would that be?
7.
7. And how did you do that? What did you do in your head?
Well, 10% is 1/10, so 70 divided by 10 is 7.
7. Very good. Okay, so you have these percentages, 50%, 25%, and 10% kind of memorized. But you can also use these percentages in this way. You can turn the percent, 50% is like 50 over 100. And then when you say of 18, you can multiply. And 50 times 18 is 900. You probably wouldn't do that in your head, but you might. Or you could use a calculator. You could do it by hand. But then, so we have 50 100ths times 18, which is like 18 over 1, is like 900 over 100. Does that make sense so far?
Yeah.
Okay, then 900 divided by 100 is what?
9.
9. So there's a different way with these percentages here where you turn the percent into a fraction, multiply it by the number that you're trying to find the percent of, and then go ahead and simplify to get your answer. And we can do that with the 25% too, just like this. 25 over 100 is the 25% of 40 times 40. What's 25 times 40, do you think? Can you do that in your head?
1,000.
1,000. Good, because 25 times 4 is 100. Add another 0 makes it 1,000. So we have 1,000 over 100, and 1,000 divided by 100 is just
10.
10. So we just use this same method here to get 10, just like we did up here to get 9. And let's use the same method here. So how would you write this one out?
10 over 100 times 70.
Good. So 10 over 100 times 70. Now keep going for me. What would you write next?
Well, 10 times 70, which is 700.
Good.
And, then
Over 100. Very good.
And then that's 7.
That's just 7, right? Okay, good. Now let's use this same method for a percentage that you probably haven't memorized. Let's do 28% of 70 instead of 10% of 70. Do you think this will be bigger or smaller than 7? If 10% of 70 was 7, 28% of 70, will it be bigger or smaller?
Bigger.
Bigger. So that's a good check in our mind. If we get an answer that's less than 7, we probably didn't do our math right. How would you set this up, just like we did here?
Well, 28 over 100, and then times 70.
Very good. And then we can do you can use probably a calculator to multiply what times what?
28 times 70.
And that's 1,960. I used a calculator to do that, over 100. Now, how would you simplify this? What would you do?
Well, if there's 100, then you can move the decimal place over twice to simplify it, which would be 19.60 or 60, so it's 19.6.
Very good. So when you divide by 100, it's like moving the decimal place twice, and you get 19.6. So you can see how you can find the percent of numbers by first turning the percent into a fraction, using that of as a multiplication, and then going ahead and doing your math and simplifying. Make sense?
Yeah.
Very good.